to Longevity Article Review number 10. My name is Jordan Marsh, and this is part 2 to Longevity Article Review number 9, which is all about ApoB and trying to understand why everyone's talking about ApoB as opposed to just LDL-C, which is the typical marker that we use for measuring our cardiovascular disease risk. And this is my attempt to understand that myself and hopefully share that with you. All right. So, bird nerd time. I forgot this last time. This is the peregrine falcon. This guy can travel at over 200 miles per hour while diving, I should say. So if they're just flying around, they're still really fast. I think it's up like 50 to 60 miles per hour. But when they're diving for their prey, they can reach speeds of over 200 miles an hour. It is the fastest animal alive, not just the fastest bird alive, the fastest animal alive. So, peregrine falcon's pretty cool. All right, so again, this is just this is a introductory article from Peter Attia about why we care about ApoB. My goal was to understand it myself and then dig more into the actual research that he cites later, so you can definitely expect that in number 11. But here we go. We talked all about LDL-C, LDL-P, what ApoB is at all anyways, and why we care. And so now it's about understanding why doesn't LDL-C, the typical marker that we use to measure cardiovascular disease risk, always work for everyone, and why do we even care about ApoB? So I want to start by just saying that there's a difference between LDL-P, or LDL particles, the total number of LDL particles in our blood, versus LDL-C, which is the total amount of cholesterol within LDL particles in our blood, if that makes sense. Okay, so it's crucial to understand this. It's crucial that we understand the difference between LDL-P, which, just like other lipoproteins, has an ApoB attached to it, and LDL-C, which is just the amount of cholesterol within LDL lipoproteins, okay? And then the next thing that we need to understand, of course, is concordance and discordance, okay? And this is crucial to understand exactly what we're going to get into later, okay? So concordance is just agreement or consistency, and discordance is the opposite, disagreement or inconsistency, okay? And sometimes there is concordance between the number of LDL particles in our blood and the LDL-C, or the LDL cholesterol within our blood. And sometimes there's discordance, okay? So let me show you that here. I've obviously put, when there's concordance between the two, what am I saying? I'm basically just saying that either LDL-P and LDL-C are both high or elevated, or LDL-P and LDL-C are both low or non-elevated, right? And so it should be noted that this is generally the case. For most people, when our LDL-C is high, that means our LDL particles are high, and that likely means that we may be at risk for cardiovascular disease. However, that's not always the case. So if it's discordant, that means there may be times where LDL-P is elevated and LDL-C is actually decreased, or when LDL-P is not elevated and LDL-C is increased, okay? And so I want to just dig into, I made this diagram on the next slide, and it's pretty intense, but I worked pretty hard on it, and I think I have a pretty good way of describing, why that might be the case, why our LDL particles could ever be high and our LDL-C could actually be low, and that's something that I'll show you on the next slide. Okay, so here on the top, I have this little key where I'm going to show you how much cholesterol, kind of like a lightning bolt, is typically found within an LDL particle, how many triglycerides are typically found within an LDL particle, so that's the star, the protein is kind of like the cloud, and the phospholipids are like the moon. And this is exactly how it looks inside your body. I hope you just know how great I've described this for you, okay? That's a joke. So yeah, there's the key, exactly what you can expect, and an average LDL particle will be on the left. So this is your average LDL particle. Typically has about 20% phospholipids. Phospholipids, remember, have kind of the phosphate group attached to the top, and then they have the free fatty acid chains on the bottom. And the phosphate groups are the ones that interact with water, and the fatty acid chains are the ones that carry all of this stuff inside the lipoprotein, all right? 50% of an average LDL particle is made up of cholesterol. Okay, so we've always heard about how cholesterol is bad for you, and And LDL particles are typically carrying a lot of cholesterol around. They're carrying about 50% of the particles, 50% of the cholesterol. Okay, 20% is made up of protein, and then 10% is made up of triglycerides. So there's 10 total. Let me just circle this for you. There's 10 total symbols there, and each of those are made up of, I tried to make it so obviously that 20% would line up with 50% and 20 and 10. Okay, so let's talk about what a cholesterol depleted LDL particle might look like. Okay, so the phospholipids will remain the same, about 20%, but now all of a sudden, maybe only 30% of the LDL, maybe only 30% is made up of cholesterol inside of this LDL particle. Okay, the protein remains the same, around 20%. However, this time we have more triglycerides. Just maybe the LDL particle has more triglycerides as opposed to the cholesterol, and now we have a cholesterol depleted LDL particle. Okay, and so what does that mean? That means that the LDL particles in our blood may be high. Maybe a patient may have a lot of LDL particles in their blood, but the LDL cholesterol within their blood is actually fairly low. Okay, and this is kind of bad news bears. Okay, this is bad news bears because it's not necessarily, according to a paper from Snyderman et al., which first made the case that we should care more about ApoB than LDL-C. They said that it's more about kind of how many shots on goal ApoB has at entering the artery wall and causing cholesterol buildup, which ultimately leads to heart disease that can lead to cardiovascular events, right? And so this is kind of, for whatever reason, some people may have cholesterol depleted LDLP just based off of their genetics or different risk factors or things that, for whatever reason, they have this type of LDL particle that just isn't carrying it around as much cholesterol. And now, all of a sudden, the typical lipid profile that a doctor will usually get is not actually going to tell us the cardiovascular risk of that particular patient. Okay, so let me show you a couple graphs from the paper that describe this. Okay, so you just need to know that there may be some people that have cholesterol depleted LDL particles, and that actually doesn't give us a good idea of their risk. And there may also be other reasons why. So I think another kind of helpful thing to think about, let me just erase this. There may be other reasons why someone may have high LDL particles but low cholesterol. And one of them is simply this. What if you just took this and, cut it down the middle, and you said, now there's only, maybe there's just a smaller LDL particle that is able to carry around less cholesterol as opposed to just a cholesterol depleted LDL particle, right? So if there's just a smaller particle, it will also have less cholesterol, and then our test will not pick that up, as opposed to them understanding that there's still a lot of LDL particles that can be dangerous for causing accelerated atherosclerosis. All right. Okay, so here is a graph that is important to see. So here let's go through it really in depth. So on the x-axis is years of follow-up, and on the y-axis is probability of event-free survival. This is kind of like a survival curve. So the probability of survival should be high for those that have low LDL particles and low LDL cholesterol, all right? And that's exactly what you see here. So here we have concordance. We have agreement between low LDL particles and low LDL cholesterol, okay? However, let's look at the opposite case. Let's say we have high LDL particles and high LDL-C. There is less of a chance of event-free survival. There is, more of a chance that they will have cardiovascular events. And as you can see, N in both scenarios is around 1,200 people. This was a large study where they followed a great deal of people and showed that around 1,200 people in both groups had concordance between LDL particles and LDL cholesterol. Okay. However, let's look at the discordant groups. Okay. So this discordant group also had more of a chance of cardiovascular events that could lead to issues for them. And N is equal to 282. As you can see, there's not as many people that have this issue, But this is exactly what we're describing in a cholesterol. This is exactly what I was describing here. They have high LDLP and low LDLC. So these people on the very bottom, I'm going to just give it one more arrow for you. This people on the bottom, they have low LDL cholesterol. Their lipid profile, their typical lipid panel would not show that they are at risk. And yet they were at risk. They had more cardiovascular events in a year of follow-up period than others did. And so you need to see that that's kind of an issue. There's some people that for whatever reason had this discordance and their typical lipid profile panel would not show that. And then of course you can see here, again, this is a smaller group. It's not as common that discordance is is present, but this group had low LDL particles and high LDL cholesterol. Maybe they had a cholesterol enriched LDL particle, but they still had low LDLP and they had less cardiovascular events from it. Okay. So, what is the actual risk factor that probably matters more than the cholesterol within the LDL particle? It's probably just how many LDL particles we have. So here there was high LDLP, here high LDLP. Both of those groups had more cardiovascular events that led to trouble. Okay, so just keep that in mind. That was a large study done, and I'm sure I'm going to dig into it more. Here's another one that is very similar. As you can see, let me just as you can see here, it's a little different. It's not a survival curve in that we're measuring the probability of survival and it's going down, but this is just the cumulative incidence of cardiovascular events, which means the incidence means if incidence is higher, that means that we are in a higher risk group. Okay, so they defined low LDLC or low LDLP as less than the 30th percentile, which meant LDLC was less than 100 milligrams per deciliter and LDLP was less than 1060 nanomolar or nanomoles per liter. And then not low, which it is kind of true that it's not necessarily high, but it's just, if people had LDLC greater than 100 or greater than 160, they were in the greater than 30th percentile of risk. And we are measuring, that's how we're kind of fleshing this out. Okay. So again, let's look at those that had concordance. So here and here, this group that follows this kind of orange yellow looking line, there was around 3,400 subjects, and here they had lower LDLP and lower LDLC, and again more subjects. There's around 1,000 that had this type of concordance between LDLP and LDLC. And so here, right here, this group had less incidence of cardiovascular disease events over a follow-up period, and these people had more. So again, because there is concordance, LDLC is a good indicator of their cardiovascular risk, okay? But then it gets a little hairy when we talk about the other subjects. So these subjects down here had low LDLP, but not necessarily, but still pretty high LDLP. They had cholesterol enriched LDL particles, but they still didn't have as many cardiovascular events. They had less events than actually the group that was concordant with low LDLP and low LDLC, right? And so they had less events. However, when they got a lipid panel, their LDLC may have been through the roof, and their provider was like, oh my gosh, like that might be an issue, right? And then we can talk about this group up here where this is my group that's kind of the bad news bears, They had low LDLP, but they had they had not low LDLP, so they had higher LDL particles, but their LDLC was still technically low. And so this was this scenario right here. They had cholesterol depleted LDL particles and they had more cardiovascular events, which is an issue for this group of people. And yet again, it's not very common. There's still less people that have this type of concern, but still not trivial either. 500 patients, and another 500 patients that were also discordant on the bottom as well. So as you can see, there's some instances where LDL cholesterol is not going to give us a good idea of what's actually going on. Why is that? It's because of this dang protein, ApoB. ApoB is on the surface of all of these different particles. They are on, like I talked about in the last one, they're on VLDLs, IDLs, LDLs, chylomicrons, and LP little a's. And it's ApoB that actually is causing, it's kind of, it's this ApoB particle that is the issue. It's not necessarily the cholesterol within LDL that's the issue. ApoB is the one that, when given enough chances, will cause damage in your arterial wall that will lead to atherosclerosis. All right. And so you may be wondering, well, why don't we just do LDLP? Well, it's not necessarily just LDLP. LDLP is, again, just here, and LDLP is only, it's still 90% of the ApoB found within our blood, but there's still other molecules that have ApoB. And so ApoB is a much greater, at least according to this paper or review, ApoB is a much greater indicator of our risk. And in the paper, he talks about how it's kind of like a stochastic process where it's just how many shots on goal do we give ApoB a chance at causing damage. Okay, so if we were to reduce our ApoB from, let's say, oh, I don't want to make that yellow. I want that to be black so you can see it. So if we give ApoB 100 shots on goal, it's going to have more of an opportunity to cause arterial damage that leads to atherosclerosis. If we give ApoB less shots on goal, we're not going to let that happen as often, right? And so I think that you can think of this as just a stochastic process, which basically just means it's a random process where, if given enough opportunities, we are likely going to cause damage. And so if we can keep ApoB really, really low, Peter Attia, is quoted as saying that, if we can keep it lower than, an infant level of ApoB in our blood, then heart disease, or all of its, all of its similar correlates like cerebrovascular disease and whatnot, that would be an orphan disease. We would basically never hear of anyone dying of a heart attack, because if ApoB was kept low enough, we wouldn't have to deal with heart disease as an issue. And yet it is the biggest killer in the United States of America today. All right. So that's ApoB. I'm going to keep going on this because I'm fascinated by this topic. I think lipidology is fascinating. But that is, I think, the best explanation as to why we should care more about ApoB as opposed to LDL-C, triglycerides, total cholesterol, or any of the other typical lipid panel things that we get. Okay, so here's 3 good things. It may be important for you to get a typical lipid profile along with ApoB and see if your LDL-C and ApoB are discordant. See if you are in that group that may have discordance between these two lab values, and see if your typical lipid profile is not actually going to give you the risk assessment that you're looking for. Okay. So not all LDL particles and the cholesterol within them are created equal. Okay, so we know that some people may have cholesterol depleted LDL particles. Some people may just have smaller LDL particles with less cholesterol in them because of it. And that's something that is good for us to know so that we can understand our risk. Okay, and then ApoB gives us the most complete picture of our risk for cardiovascular and cerebrovascular disease. All right, here's 3 things to consider for the majority of people. Like I said, if you go back to those graphs, the majority of people, LDL-C still works fine to predict cardiovascular disease risk. So if you're kind of like, well, I'm likely in that group, or maybe I just don't care to do all the work, I guess you could say, I'm just going to kind of follow what my doctor says and still continue to use LDL-C. ApoB is still not routinely ordered by most providers. So you'll have to ask for it, and you'll potentially have to pay for it because it's not necessarily the standard of care yet. But you can also get it done yourself. There are certain websites online where you can go and get lab values drawn, and you can see it for yourself. And that's something that you can explore if you'd like to as well. And remember what I talked about last time about how, typically guidelines follow, typically guidelines are given and it takes time for those guidelines to percolate into mainstream clinical practice. And I do think that over time, ApoB is going to do that percolating, all right? There is more to cardiovascular disease risk than just lipoproteins. So it's not just this, obviously, you still have to be mindful of your metabolic disease risk factors and other things that may contribute to accelerated atherosclerosis, and like maybe high blood pressure or, obesity or diabetes or any of those things. And so just remember that there's more to it than just this, but this is kind of, I think this is kind of like this is the main player. This is the star of the show when it comes to reducing our cardiovascular disease risk, is just bringing ApoB down and keeping it down as best we can. All right. Thank you very much. I'm excited to keep going. We'll see you in the next one.